In this video, we're going to talk about the process called completing the square. What we're really doing is looking for methods to solve quadratic equations. So you might remember that a quadratic equation is an equation in the form ax squared plus bx plus c, and we set it equal to 0 to make it an equation. And prior to this, when we were solving quadratic equations, like this first example, what we do is factor. So I'm going to do that. I'm going to go ahead and factor this. I can use my shortcut. And this is going to be, let's see, negative 42. Two numbers that multiply to be negative 42, but add to be negative 1. Here, let me zoom in just a smidge. Okay, that's going to be negative 7, positive 6. So this is going to factor into x minus 7, x plus 6. And then we set the two things equal to 0 because we have something that's multiplying to be 0, which means one of them must be 0. And I get x equals 7 and x equals negative 6. All right, great. And we've seen this before. Let's look at this next example. This example can actually be solved two different ways. So if we use the factoring method, we would use a difference of squares, and it would factor into x minus 6, x plus 6, and then setting those two things equal to 0 is going to give me x equals positive 6 and x equals negative 6. Okay, so that's using the technique we learned before, but we learned a new technique, which is instead of factoring, we could actually move the 36 over and say x squared equals 36, and then take the square root of both sides, which would give me plus or minus 6 because we're working with an even power. So that would be the same answer. I would still get positive and negative 6 like I just got above here. Okay, so either method works. And what we're now seeing is that we have a couple different methods for solving quadratic equations. But we need to learn a new method because let's look at this example right here. In this example, there's no way to factor that because I'm looking for two numbers that multiply to be 1 but add to be 4. That's impossible. There's literally only two numbers that multiply to be 1. That's 1 and 1, or it could be negative 1 and negative 1, but they are not going to add up to 4. So this doesn't work. It can't be factored. And if I try to move the 1 over to the other side, that 4x ruins it. It can't be solved using the square root either. So what we're going to do in the next couple sections is create some new methods for solving. Up to this point, we've done factoring, and then we've used the root property, where you take the radical of both sides. But now we're going to learn completing the square. And this method is foolproof. It'll always work. We do have a fourth method, and I'll go ahead and spoiler alert. This is going to be the quadratic formula. And the quadratic formula also always works. So these first two methods that we've learned only work in certain cases, only when we're factoring or only when we can take a square root and get rid of our exponent nicely. But completing the square and quadratic formula, they'll work in every single case. Now, completing the square is not the more desirable of the two methods, but we need it in order to do the quadratic formula. So we're going to learn the method, and then we're going to use it in the next section to help us create the quadratic formula, which is the better choice for us. However, you do need to know completing the square for anybody moving into calculus. It's a technique that's used not just for solving quadratics, but for some other things that we'll be needing in the future. So we are going to learn the technique, even though it's not the most desirable of the two. And when we're given the choice between completing the square or the quadratic formula, we're going to pick the quadratic formula. But we do need to know the process of completing the square. So let's go through the steps. And actually, when I do that, I'm going to come back up to the example I just abandoned and said I couldn't solve. And I'm going to solve it using the completing the square steps. So here, I'm going to write it over here just so I can reference it. I'm going to do my best to try to squeeze this in. Hopefully I gave myself enough room. All right, so for completing the square, I'm going to refer to the A, B, and C, all right, for doing this. So first thing you want to do is you want to move the C term to the other side. The right side. And I'm referring to when we're talking about this being ax squared plus bx plus c. So c in this case is the 1. Excuse me. So I'm going to move the 1 to the other side. And I'm going to do it in a different color just so I can kind of keep track. So I'm going to minus 1 from both sides. And what I'm left with is x squared minus 4x. And I'm going to leave a blank space there because we're going to fill something in there in the next step. Oh, sorry, not equal to 0, equal to -1. Just kidding. There we go. Okay, second step. If a doesn't equal 1, then divide every term by a. In this case, our a does equal 1, so we're done with step 2. We don't have to worry about step 2. But if it had been like a 2, that means I would divide every term by 2, including the -1 on the right side there. And we'll see some examples where we do that. By the way, these first 2 steps are interchangeable. It doesn't really matter which one you do first. This is the order I go in, but sometimes other people give it in different order, and it's the same thing. Okay, but here's the important step, step 3. So step 1 and step 2 have to happen before step 3, and here's step 3. So we're going to take half of the b term, which in this case would be -4 in our example. We're going to take half of the b term. There's no e on the end of that. That's funny. Let me erase that. Half of the b term, and then we're going to square it and then add that to both sides of the equation. So in this case, we'd be taking half of -4. So half, and I like to do the work over here on the left. So half of -4 is -2. And then I'm going to square -2, which is going to be 4. And that is what I'm going to add to both sides. So in that little blank space I left, I'm going to put +4 on both sides. So here's what I have. On the left side, I have x squared minus 4x plus 4. And on the right side, I have 3. Now here's the magical step. That was the big important step because this is going to allow us to do something. It's going to allow me to factor the left side into a perfect square trinomial. And then I'm going to solve using the root property. Let me show you what that looks like. So the left side is going to factor into, so if I say what 2 numbers multiply to be +4 but add to be -4, that's -2 and -2. And it's always going to factor into something squared like that. That's the point of this method, is it completes a square. It gives us a square because now I can use the root property to finish solving this problem. So I'll take the square root of both sides. On the left side, I'm going to get x minus 2. And on the right side, well, I can't actually take the square root of 3. So I'm just going to put my plus or minus in front and leave it as a square root of 3. And then I'm going to solve for x by adding 2 to both sides. Now, I can't really add 2 to the square root of 3. They're not like terms. So I'm just going to put 2 in the front, plus or minus square root of 3, and that is the answer. It's an ugly answer, but I couldn't have gotten that using factoring, which is why we need this method. So we're going to try this again, each step again, and then I'm going to show you something kind of magical after our next example. So let's try another one. So the first step is to move the 48 to the other side. So I'm going to minus this 48, and I have 2x squared plus 20x, I'm going to put blank, equals -48. All right. Second step, if A it doesn't equal 1, we need to divide everything by A. So in this case, A is 2, and that's not 1. So I'm going to divide everything. Oops, I tried to switch that over to red. Everything by 2. And what that's going to give me is x squared plus 10x equals negative 24. Now, step 3, the big important step. I'm going to take half of the b term, which after dividing is a 10. So I'm going to take half of 10, and then I'm going to square it. So half of 10 is 5, and 5 squared is 25. So I'm going to add 25 to both sides. Now, on the right side, oops, let me switch back to green here. On the right side, I'm going to just get 1. But the left side is going to factor into a perfect square. So two numbers that multiply to be 25 but add to be 10, that's 5 and 5. So this is going to factor into x plus 5 squared. Now, I'm going to take the square root of both sides. So on the left, I just have x plus 5. And then we can actually take the square root of 1. The square root of 1 is just 1. But I'm also going to put in the plus or minus. So now I have two equations. I have x plus 5 equals positive 1, and x plus 5 equals negative 1. So this one's going to give me negative 4, whereas this one's going to give me negative 6. All right. Now, quick comment about this step where we factor it. Notice I wasn't using the X method. I kind of was saying it out loud, but I didn't really use it. And here's why. I'm cheating. This number that we get right before we square it is always what it's going to factor into. It's going to be, so because that's a 5, it's going to factor into x plus 5. Up here, it was a negative 2. And look, it factored into x minus 2 squared. So I'm going to use that from here on out to help me factor. I mean, you can use the X method. It would work. But there's going to be some problems that'll be kind of ugly, and you're going to want to know this nifty little trick. So let's try another one using all 4 steps again. That'll be a little bit grosser, for lack of a better way of saying that. Okay, so first thing we're going to do, we're going to add 2 to both sides. And that's going to give me x squared minus 3x equals 2. And I leave that little space. Step 2 is actually done because a is 1, so I don't need to divide everything by 1. So on to step 3. I'm going to take half of b and square it. Okay, I actually can't take half of negative 3. And I'm not going to go ahead and divide it on the calculator. I'm just going to leave it as a fraction. So that means I'm just going to go ahead and square this. And that's going to become 9 over 4, right? Negative 3 times negative 3 is positive 9. 2 over 2. I'm sorry, 2 times 2 is 4. Okay, so I'm going to add 9/4 to both sides. So getting my calculator, I could add 2 plus 9/4. Okay, but I happen to know 2 is 8/4. And 8/4 plus 9/4 is 17/4. Okay, but on the left side, I need to factor this. And I'm going to factor it using my little trick. So because I wasn't actually able to divide by 2, that's what it's going to factor into. This is going to factor into x minus 3/2 squared. Gross. All right. Taking the square root of both sides and pretending it doesn't freak me out. On the left side, I'm just going to have x minus 3/2. But on the right side, I need to work out that radical. And it's been a while, I'm sure, for many of you, but you can break up the radical over a fraction. So I'm going to rewrite it as the square root of 17 over the square root of 4, and I also put my plus or minus there. Now I can't take the square root of 17, but I can take the square root of 4. The square root of 4 is 2. Okay, So now to finish solving for x, I'm going to add 3 halves, but I can't actually add 3 halves. They're not like terms. I'm just going to stick it in the front. And this is actually a perfectly acceptable place to stop for our answer. You can, if you want, and maybe mom wants the answers written because it has a common denominator. I could be clever and write it all over 2, like as one fraction. It might want your answers that way, but either way should be exactly the same thing, and it should accept both answers. So both answers would work.